discuss about our maths assignment. So before we proceed on further, let's introduce ourselves. My name is Dinesh Chandrasekhar, metric number 177851.
My name is Leong Shijang, 1800762.
Hello, my name is Ali Ahmad Maslan and my metric number is 178424.
Hello, my name is Muhammad Anas bin Muhammad. My metric number is 177854.
Okay, my name is Muhammad Nazradam bin Fauzi, 179088.
So me and Leon would like to present about question number 1 first. So Leon will start off with our discussion.
Okay, so here is our solution for question 1, and I would like to say the question is not included here, only the solution. And let's see, the question actually given us hash equal to 50t minus 4.9 t squared. This is the type of function given by the question. Is like projectile being thrown vertically with this function, and we want to determine the maximum height the ball can reach. So first of all, let's see, a equal negative g is given, and we know that a equal to dv over dt. If we integrate the v, and we will get integration minus g dt, and then divide it. This is the negative gt plus c. So we know that when the ball reaches the highest maximum height, it is a t equal to 0. When we substitute the t equal to 0, we can find the v equal to 50. You see, when we substitute t and c, well, I mean the highest velocity is 50. So we substitute t equal to 0, we get the c first, then we get the true equation. Okay, let's move down, and we see that this equation, if we substitute, the velocity is 0 at the highest maximum height. Then here we can use the find the t by dividing 50 to 99.81. We get 5.1 seconds. This is the time which it reached the highest. And then as the same equation, we substitute t equal to 5.1 seconds, we can get the highest height, which is 127.6 meter.
Hello everyone. So now I would like to talk about the sketching part of this question. This is the sketch, just a normal sketch of the projectile movement with respect to time based on question number 1. So to get this sketch, first of all, what do we do? What information we gather is that, first of all, we have the information that the time taken for it to reach the maximum height when velocity is 0 is 5.1 seconds, and the descending time for the projectile to reach from the maximum height to the ground is 5.1 seconds as well. Thus, the total time of the projectile in motion would be 10.2 seconds approximately, and the maximum height achieved by the projectile when it's launched vertically at 50 meters per second as an initial velocity would be 127.6 meters. So with this information in mind, as well as with this equation, h equals to 50t minus 4.9t square, which is a parabolic equation, we can plot a graph which has a parabolic characteristic with respect to time. This height as well as time with respect to time, and the height is in meters, time is in seconds. As you can see, the maximum height is approximately near to 5.1 seconds, and the time for it to finish is approximately 10.2 seconds. So that's all. Thank you.
Okay, now I have been solving for task 2, which is question number 2, which is about Maclaurin series. Okay. Okay, this is that my question about it's about to find the first three non-zero term of cos x squared. Okay, and about to solve from range 0 till 1 in about 4 decimal point. Okay, this is my question about from range 0 till 1 of cos x squared. Okay, first we just focus on this one first from Maclaurin series, which is cos x squared, that we solve first. Okay, this is first equation, and we differentiate for the second, which is become prime, which is becoming negative 2x sin x squared. How to solve it, you can further refer to book. For this, to further the differential equation, it's becoming more difficult. And how I solve it? Okay, I use the product rule, which is you just let u as negative 2x and sin x squared become into v, which is u negative 2x and u prime is negative 2, while v is sin x squared and v prime is 2x cos x squared. This product rule, and you can solve for the other primes, anti-prime. Okay, then we proceed the let x equal to 0 and substitute it to all differential equation. For solving the Maclaurin series, we must obey its rule, which is about for 0, which is the first equation that we use 0, plus x, the first prime of 0, plus x squared over 2 prime times function second prime of 0, and until the last the 8th term. Then
Tekan ini. Soalan ni step dia banyak missing.
okay, this is and the solution that I have been solved from f1 until the 8th term for differential equation. And when x equal to 0, you can see the pattern of 0, 1, 0, 0, 0. That the equation that been asked about the first non-zero term, which is the equation, the answer must not equal to 0, which is the last one is not equal to 0, 1860. And after obeying the Maclaurin series rule, you can see this equation that have been got, and this is the last one, the final equation. As the equation mentioned, question mentioned about the from range 0 till 1, you can see the pattern. Just differentiate, just substitute the cos it by this one, and just integrate just as normal, and you can get the answer 0.9046 for 4th decimal point, which is mentioned by the question. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for this project, my task is to do the third question. Okay, let's begin our solution.
Yeah.
Okay, for our question, this is our question for this task. Okay, this is the example, not the example but the question in this assignment. Okay, first of the question asks for dy squared over ds squared, d2y over ds squared. Okay, he give us the value of x and the value of y. Okay, first step is we must find the differentiate of dx and dt first, and let's begin. Okay, for dx over dt, we can simply say that sinus omega t. Okay, this is for dx over dt. Okay, let's find the dy over dt. Over dt. 2 omega r cosine omega t. Okay, when we reach at this part, this is not the last solution. We must to find the double differentiation. Okay, as we know, dy squared over ds squared equal to dy squared over d kali times d equal to this. Okay, what we must find is this and this. Okay, we find this first. D sorry for my mistake. This is actually like this. Okay, we proceed like this.
Can you make another one? That's question.
Okay, sorry. Okay, d2y over ds squared equal to dy this d squared y over dt squared times dt squared over d. Okay, we get this. Okay, what we must find is this and this. Okay, for d 2x over dt squared, we get okay, from this, and we must find this. We get negative r omega squared cosine omega t. Okay, and for this d 2y over dt squared equal to negative omega squared r sine omega t. Okay, so we get this, and this time for we to times it. Okay, d2y over dt dt squared over d at. Okay, we write again this. And for this we change, because we want to cross multiply it, minus 1 over okay, so we get this for this solution. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Ali Ahmad bin Mazlan. So I will proceed with the last question, which is question number 4. So for the question number 4, it is about application question. So I will show to you the questions. So for the question number 4, as I mentioned just now, it is about applications question. So first of all, this question we have to analyze what it wants. So this question wants us to prove that it gives the formula, which is P equals to IV, and then it gives the value of I and V. So we have to prove this solution. So this is solution number 1, and we have to prove to become it solution number 2. So first of all, we have to know what is the rule that we can use to solve this question. So it is easier for us because sometimes it give the formula, and there are some several formula we can use to solve this question. So I will proceed to the solution of this question. So for this question, we can use product to sum formulas. What is product to sum formulas? There are 4 of them. So I will just straight to the answer, straight to the formula that we will use to solve this question, which is sin u. This is the general formula of the question. Sin u times sin u equals to 1 over 2 cos v cos u minus v minus cos u times plus v. So this is the general formula of the product to sum formulas. So we will use this formula to solve this question. So we make it simple. We take it u as omega t minus this one, and then v is omega t, and then we can do according to this formula. We can use this formula to answer this question. Sin u means that we enter the value so it will become like this. This is I and this is V, and then we can just straight answer this question. We take out I and V, and it will left sine and sine. So we take out 2 I and V, it will become 1 over 2 IV 1 over 2. We follow this formula, cos u minus v, and this is u, this is v. So we can just straight enter the value omega t minus omega t, and then minus cos u plus v. We enter the value omega t plus omega t, and then this is the final step. We write the answer, we arrange the answer. Omega t minus omega t, it will become cos minus cos omega t plus omega t, it will become minus. So after we have done this solution, we can see that there are difference about this formula, but as the rules of the cosine rule, we know that if cos minus x, it is same like cos x, and then we can just arrange, we write the final answer. It will become cos minus cos omega 2 omega t minus, and this is the final answer. So this is proven. That's all from me. Thank you.